field. He is an engineer. I'm an architect, so he is more in tune with the challenges that the engineering field is experiencing as far as BIM is concerned, because there's been a slow adoption on that side. So hopefully something big will be coming up very soon. Anyway, enough of that. I was actually buying time so I can join in with my device. And to confirm that my screen sharing works. So Martha, please confirm to me that both my audio and my screen are okay.
Yes, they are perfectly fine.
Thank you. So everyone, welcome to this Innovate 360 talk, where I'll be talking about the evolving landscape of technology in engineering, particularly civil engineering. However, a better title would be the evolving landscape of technology in AEC, architecture, engineering, and construction. Or you can even say IECOM, AEC or M, architecture, engineering, construction, operations, and maintenance. Because largely the technologies that have been developed for this space are being used cross-disciplinary across the fields. They may be used differently, but they're largely the same technologies. So essentially my talk will be split into two, and that is I'll speak about trends in technology first, and then BIM. So my name is Boit Bran. I am a graduate architect working at a company called Biosystems Consultants team, BSc team. If anyone of you is active on LinkedIn, you probably know architect Duncan Odhiambo. Anyone who is active and is interested in architecture. Architect Duncan Odhiambo, that is my boss. That's a guy I see someone know him. Yeah, that's a guy I report to. Yeah, that's where I explore my architectural exploits. I am also a founder of a design venture called Akani Group. Akani Group is essentially a design lab where we explore different architectural digital tools, particularly BIM and a bit of AI in our projects. And I'm also a committee coordinator in a company, in an organization, in a not-for-profit organization called BIM Africa. BIM Africa is working towards advancing the gospel of BIM in Africa. Right now, we're actually working on Africa BIM Report 2024, where we're trying to study projects in Africa that are implementing BIM, speaking to opinion leaders in Africa who are deploying BIM, and also just rolling out a survey to assess the progress of BIM in Kenya. So I have a personal interest clearly in BIM and heritage BIM, that's BIM for conservation buildings. I have a personal interest in architectural design itself, in AI, artificial intelligence, and particularly as it applies to architecture and in architectural conservation. And that's essentially my previous experience on the screen with BIM. So today I'll speak especially about two things. I'll just introduce tech, speak about technological trends in the AEC space, BIM, and then conclusions and questions. I'll not go into much depth on either of them. This is more of an introductory session, and I know I'm not speaking to particularly experts, but I believe these are students who are enthusiastic about trying out technology and seeing where the future is going. So I'll just be touching things here and there so that you have a feel of what is happening in the world outside there. And so that then if you want to go deeper, obviously I'll not be the best person to take you deeper. I would probably do that better with architects and with engineers. I appreciate WIE for what you guys are doing, women in engineering. That's amazing. I worked closely with WIE in TUK. I also appreciate IEEE. That should be which society was this? Okay, it has escaped my mind. That society that's organizing this. I appreciate the work you're doing. I was a member of IEEE in TUK. We organized the first symposium in TUK 2021. It was amazing just seeing what students can do. And my experience in IEEE really has been that, when you are in IEEE, the people you interact with in the mentorship sessions, in the conferences, are not your typical um, lecturers or run-in-the-mill engineer, still using hand calculations from 1970. You interact with people who are at the forefront of the deployment of technology, and the people who are moving the industry. And so when you get used to interacting with such people, they open your mind to think big. And that was my experience with IEEE. And then after I finished school, I I published a paper with IEEE Explore after doing a conference presentation. And interestingly, the paper I presented in IEEE Africon 2023, Africon Nairobi 2023, was a build up on a project I did in school. I'm just sharing this because if the majority of you are students, then I want you to believe in the work you do in school and realize it is not a small thing. It is, you're not just doing this for the sake of finishing school. It can actually go higher than you imagine. The photo you're seeing on the screen is a project, is a live project in Mombasa. It's a conservation project in Mombasa. I was to do that for my school project. I did something a bit different. I did a different site, but the same principles, deploying BIM in conservation projects. As soon as I finished school, I went to National Museums of Kenya with the work I had done. I got a job there. I worked there as a volunteer. And based on the work I did in TUK as a student, as an undergrad student, we deployed BIM for the first time in documentation of conservation projects in Kenya by the National Museums of Kenya. Right? It was the first time NMK was deploying HBIM in conservation projects based on my paper. After that, I partnered with those who had supervised my project, two of them, and we of course took it a notch higher because IEEE are not your normal project supervisors, so you took it a notch higher, then published a paper. So wherever you are, just know that if it's your desire to do something great, you can do it even as a student. I could share many stories, but you don't have time. So yeah, that is an experience. I just appreciate all those bodies that have gone into organizing this. You guys are amazing. All right, let's get into it. So, what is tech in engineering? What's tech in engineering? And tech essentially, that's the use of innovative tools, innovative systems, innovative processes to design, construct, and manage infrastructure and systems. The graphics there, that's on top, that's intelligent transport system, ITS. Second is intelligent water management system. Apochini was an intelligent urban management system. So essentially, tech is all about systems, and that is anything that you see around you is a system of many things working together. When you see vehicles on the road, it's a system. It's a system involving traffic lights and the road design itself, and policemen who are policing how you use the road, and drainage system, and fire system, and road accidents, and all these things happening together for you to make traffic move efficiently. And so the idea behind technology and engineering is that when you study, every system you see has its own losses. There is some, there's wear and tear somewhere. There is time loss. There is data loss. There is communication breakdown at some point. And so the idea behind technology is that when you study these systems in operation and you go to a building site, it's a whole system. It's a system involving manufacturers of fixtures and fittings, involving different practitioners, architects, engineers, quantity surveyors, the contractor himself, the client. It's a system of buildings and machinery and equipment and a plant, and shops. And so all these players and equipment, then create a system. And for you to stand there and ask yourself, where are data losses happening here? Where is the communication back happening here? Where is labor losses happening here? And you thinking, how can I use technology to avoid these losses? So that's the whole idea behind technology in engineering. I hope that makes sense. So there is software, there is hardware, there is digital solutions, and it's all about enhancing efficiency, accuracy, and a new idea is sustainability. Okay. Now, there's a video here I want you to watch as we continue. It's a video I came across. I'm also a student at LX. I am um, I'm studying design. I'm studying data science. Sorry, I'm just saying that there's a text here. I'm studying data science at ILX, and because I just think I want to go deeper and deeper into tech. And while studying there, I came across this video which I think was just motivational. So I'm not sure if my audio works. So I hope it does. If it doesn't, I will be disappointed.
Why some say the book? Why choose this as our goal?
Guys, sorry, and that's unfortunate because now that will happen for several of that. Okay, for the sake of time, as I'm trying to now multitask and solve that problem, I didn't realize it would redirect to YouTube. So it's a video. It's a 1 minute caption. It's a 1 minute. It's 1 minute portion of a speech by JF Kennedy. The speech was given in 1961, and essentially he is explaining why they want to go to the moon, right? And so he's saying that by the end of this, so by that time, of course, there was this space war between US and Russia, and everyone was competing to be the first one to go to the moon. And so JF Kennedy is explaining why he thinks going to the moon is important. And essentially, JFK says that it's because no one has done it before. That's why we have it's expensive, it will take sacrifice, but we have to do it because no one has done it before. And it was just impressive to me, you know, that JFK intentioned to do something which no one has done before by the end of the decade. And it has been called the moonshot video. And so um, the question I would want to ask you today is, what's your moonshot goal? What is that one thing that it's a dream beyond your abilities. It's grand. It's not done before, but you're telling yourself, this is what I want to do by the end of this decade. By this decade, I want to have deployed AI in civil engineering. By the end of this, what's your big goal? What's your scary goal? What's that one thing which has not been done before and you want to do it? Anyway, that video has disappointed me, so we'll just proceed. And now I'm not a very good taking. This is what happens when just allow me to stop sharing for a minute, then reshare. Apologies for that. Sometimes these things happen and they embarrass you and you're talking about tech. And then PowerPoint becomes the problem. So we'll now go We'll now go into some technology trends. So we'll fly quite quickly because of that. So several trends in technology which I have seen happening, which I think you might be interested in. First is digital twins and IoT. Right? I would have asked what IoT is, but I assume you know. Basically, the idea behind digital twins is that you create a virtual replica of a physical asset, a building, a bridge, a machinery, and and so you create it as it is, and then you probably have devices that you use to collect information used to create this model. Let me give you an example. An example of a digital twin is when you create a bare model, and a Revit model of a building that is going to construction. So it is a virtual replica of something happening on ground, right? So that's a digital twin. Now, an example of IoT devices is, let's say you're on site. You have all these workers working on site. You want to know the location of every worker. So what do? You give them something they can wear, which shows their location. That's a wearable device, and it's all connected via internet. So, right? So that's an IoT system. In let's say, because civil engineers, we probably deal with water systems. You probably have sensors that measure real-time water quality, or on the roads, you have sensors that measure traffic flow. And actually, I'll come back on that again. Right? So I have a friend who was in JQuat, and he did a project for his final year that was basically about using machine learning to study traffic so as to regulate traffic lights. So the traffic lights open based on how many vehicles are on a certain road. So he had devices which were studying the cars and communicating via internet. Right? So that is an example of an IoT, studying traffic flow, studying energy consumption. Right? So that's basically what an IoT is. It's of course an upcoming field, and studying what devices can be used to collect what kinds of data. And so some of these devices are sensors, others are wearables, others are systems for maintenance. Right? There's a company I was reading about where they're clearance and forwarding companies. So they have all these cranes that clear stuff, and usually they used to suffer from downtimes when a crane suffers. So they installed IoT devices that detect whether a crane is nearing failure or not, so it can be maintained before it fails. That's an example of an IoT maintenance technique sensor. And then current site map is basically geolocation using IoT sensors. So that's one trend that's happening in engineering, IoTs, and then digital twins. I'll come back to digital twins that's talking about BIM. Another trend is AI, that's artificial intelligence and machine learning. Now, the idea behind artificial intelligence and machine learning is essentially, so artificial intelligence is whenever you use computers to do things which usually depend on human intelligence. Now, one place where AI has been really used is in the automation of repetitive tasks. Right? There are probably some tasks which you normally do. You probably design a structural engineering system, and then you document, you detail it, and then now you need to document it. Probably you want to send it for approval, so you save it as PDF, so they go to approvals, and so you're always doing that process, designing, detailing, which is actually what your brain as an engineer is meant to do. And then you do this clerical work of documenting it on PDF. So with AI, basically you let the computer learn that. So machine learning is basically training a computer using data to learn how to do certain things which you normally do. So you probably train your computer to learn that, so nikishafika hii level, I just export it to PDF and then save it and probably send it to whoever. And so you automate that process by teaching the computer to do that. So probably one thing which you might want, if you want to go into that field, one thing that you might be interested in being keen to notice is whenever you go into any system, you go into any site, you go into any into any company. Ask yourself, what are some repetitive tasks which we are doing here that don't really need us to do it as engineers? Saving a document as PDF does not need 5 years of engineering education. So what are some of these tasks that are repetitive? And then how can I automate them? That's the whole idea behind using machine learning to create artificial intelligence systems. Okay. So AI is also used for personalization. Those anytime you go online to shop, it's AI that makes you to see certain adverts. And then there's something called generative AI. This is probably the more common kind of AI that we know. Generative AI is basically when AI generates information based on prompts. Right? So on the side, I have 3 logos of 3 very common generative AI tools. Let me see. If you know any of the tools there, type in the chat box. Ahmed, I'll send the link. I've seen your message. Please send us the link. We'll watch later. Jim Karanja, digital twins are not as-built drawings. As-built drawings are drawings you create of a building already built. A digital twin usually is prepared. It can be prepared both after the building has been done or before the building has been done. Anyway, I think for what I can actually do is, at any single point when you have a question, just type it in the chat box. Then once I'm done with this talk, I will respond to all of them together. Now, quick response. If you know any of the logos on the side, if you know what company that logo is, post in the chat box. Just type the software if you think you can identify any of the logos. Seeing Jim has already identified the first Jim Ahmad, the first ChatGPT. I think that's what most of us know. The first logo is ChatGPT, and Ahmad knows also the second one is DALL-E for image generation. The third one is ChatSonic. ChatSonic basically integrates ChatGPT and DALL-E. And then ChatGPT also has, ChatSonic has this ability to interact with documents outside the platform. ChatGPT cannot go outside the platform. You can only chat with it. With ChatSonic, you can even import PDFs, and then when you want to revise and you don't have enough time to revise, and you know that there's a question you have and the answer is somewhere in your PDFs. So with ChatSonic, you can just import the PDFs ChatSonic, then ask ChatSonic, what is this and this and this? It's in that PDF somewhere, right? So generative AI, that's what generative AI does. It generates responses based on prompts. So for me as an architect, I've used generative AI to do design conceptualization. What you see down there, the 4 images, I modeled the first image, but then I wanted to get different feels of what that project can be. But I don't have enough time to try give me a tropical scene, give me a beside the sea scene, give me an urban scene, give me a modern scene. These are things which architects try out. And so I just used AI to prompt. I prompted this one. I used software called Veras. So I just uploaded my model and I was like, okay, I want it to look like something done by Zaha Hadid by the sea. Right? Then I'm like, okay, give me something a bit more modern with some timber feel. And that's how I got the 3 ideas. So I've used it a lot for quick conceptualizations when I have a project and I want to get different ways in which it can come out. And sometimes, I end up now combining different ideas. So that's one use of AI that I've applied in my architectural practice. And it really helps us to save time. This was another thing I did with generative AI. Anyone who knows which building that is? The ugly building on top. So what I did here was using generative AI for design criticism. Yeah, I know everyone knows what it is. So I used generative AI. I'll not even mention what it is. To try and prompt, how else could it have been designed? And we did several iterations. I also see TG joined the meeting. TG Mureithi is in the meeting. I've seen his name in the meeting. TG Mureithi is my partner my business partner at Akani Group. He's actually the managing partner. His co-partner there. Yeah, so we are doing this project with him. So we are trying out different iterations with that building over there. Yeah, but anyway, it works. People say that it looked like something designed by an engineer. I think that's offensive to the people in today's session. Anyway, the other thing is data analytics and big data. Now, this one also had a video. It's a 2 or 3 minutes video, but I doubt it will play, because when I played it, I remember there used to be a setting I used to do for, so that it picks the audio. I'm not sure what it is, but anyway, it's a 3-minute video. It talks about a project called the City Brain. So the City Brain is a project deployed by Alibaba, where he basically created this system that studies traffic in the whole city. Marked the position of every vehicle, using basically these IoT sensors, and then using that information to control the traffic of the whole city. It was like a whole ITS brain, intelligent transport system brain. That's what it's called, the City Brain. So it knows when it studies and knows when traffic is about to build up before it builds up because of machine learning, and so it now controls the traffic lights to prevent that build up, and that's amazing. So basically, data analytics is that process of collecting data and trying to identify trends in it. That's the first step when you're going towards machine learning. So you first of all analyze the data, and then once you have studied the data and you can identify trends, then you create models so that you can be able to predict the future. That's now data science. So data analytics is just analyzing data. Data science is now when you can predict the future. Now big data is now when you can collect massive amounts of data and now use it to create these prediction systems, right? That's now where big data comes in. So when you're collecting a massive amounts of data, identifying patterns in them, and then using them to make predictive decisions, like now what these guys are doing at City Brain. Let me see if it will embarrass me again. Yes, it will. Okay. So no need to be embarrassed for long. You just go to the next thing. It worked.
我早上4点半我就起来了，我起来也反正早上夜的那时候不懂嘛。
在杭州开了9年出租车的赵师傅，每天凌晨提前2小时出车，就是为了躲避拥堵。在这个城市里，每天有200多万辆机动车，9000多辆公交车，还有无法计数的非机动车穿行其间。
从我们的专业的直觉来讲的话，到那么复杂的系统的话，它本来优化的一定不够好。
堵车几乎已经成为城市生活的一种日常，但幸运的是，城市里还有另外一样东西，也在每时每刻都在发生。它就是数据，视频监控记录下每辆车的行驶状况，线圈记录下这些车辆的行驶速度和数量。
抢单成功。
出租车司机每日用手机接单，运行轨迹都被保留下来。公交车上的刷卡机记录下有多少人在什么时段乘坐了公共交通。
当城市有数据的时候，实际上需要的就是怎么来建立一个城市的大脑，让数据呢能够帮助城市来做思考，来做判断。
杭州市政府牵头，联合了包括阿里云在内的13家企业，成立了城市数据大脑专项小组。
政府的数据应该是大量的，它不仅掌握着政务方面的数据，而且还掌握着大量的社会数据。这个数据你沉淀在那边，它是没有价值的，只有把它开发出来才会有价值。
城市大脑的第一步就是尝试用数据和算法来改善交通问题。路上的摄像头每天都在不间断地记录数据，全程的5万多录视频，如果由交警3班倒的去看，需要15万个交警。通过算法，机器可以在短时间内把这些视频都看完，数清楚有多少辆车往哪个方向走了。
那碰巧呢，我们自己的这个专长又在云计算上了，至少 我们说不能彻底解决问题，但是有条件至少来改善这个问题。
阿里云自研的飞电系统支撑了实时采集、快速读取这些数据所需的无法想象的计算量。科学家们还尝试挑战用数据来优化红绿灯配时方案，希望它能实时计算出城市里8万多个路口每一刻的交通状况，并在毫秒间做出决策。
是拿数据来解决交通问题，但实际上用今天比较时髦的话来讲，其实涉及到图像识别的问题，涉及到人工智能的问题，涉及到视频处理的问题，涉及到云计算的问题，涉及到几乎你可以想到的这个都会碰到了。
9月，城市大脑在世新路初步试验，平均车速在某些路段提升了3%到5%，在部分路段有11%的提升，真正开始了用大规模数据改善交通的探索。
我理想当中城市大脑就是说，一个城市可以为老百姓，可以为这个社会创造价值的数据，都应该在这个大脑上。我们的各个企业可以很好的利用好这部分公共资源，来创造出新的价值来。同样呢，政府也可以用好这些东西，来更好的服务管理这个城市。
Amazing. Hopefully you got an idea of how hopefully we've gotten ideas of how such systems work to using IoT to improve transport systems, which is, and the idea behind this is I hope I'm still audible. Someone confirm.
Yes, you are.
Okay, thanks. So the idea behind that video is studying how can you use tech to improve what you normally do in your field, whether as a civil engineer you're going to water system, or going to roads and highways, or you're going to structures. So that's someone who, as a Kenyan engineer who did a project in information traffic management system. Then there's the use of generative AI. I'll not go a lot into that. Then there's robotics and automation. Because of time, I'll not play this video. This is a video of a robotic arm doing bricklaying. So robotics has gone into bricklaying, 3D house printing, and the likes.
The first home ever constructed.
Allow me to jump this. And then there is AR and VR, that is augmented reality and virtual reality. So essentially, this is when you create a digital model, right? So you create a digital model using Revit, using any of the BIM modeling softwares, Archicad, Dynamo, and the likes, and then you now use VR, probably VR head-mounted devices or VR glasses to be able to immerse yourself into this 3D model, right? So that's virtual reality. Actually, augmented reality is when you're not just going into this model that you have actually modeled, but when you can overlay the model on reality, right? So, for instance, on the first image, that is someone using AR to do project inspection. So essentially, in his phone, he has this 3D model, and then on site, the 3D, the whatever is in the 3D model is under construction, and so he can compare. If you've ever used 3D glasses, you know that you're in the space. When you turn, the model turns. You experience the model in 3D. So now with AR, it's the same thing, but now you see the 3D model in actual real-time space. So you can compare the model with what is actually on the ground and stuff like that. So the second image is a 3D model of a project we did in Uganda. So you're created using photogrammetry, and it's like an image, but now it's a 3D image. So you're using it to remodel it. So that's one thing which you used. And then the other technological trend is sustainability and green technologies. That's green materials are becoming a common trend, and in Kenya right now we are working towards, green building certification is becoming a big thing. EDGE, that is excellence in design, and hey, why is the GE disappearing? Even did the competition anyway. So EDGE is they have a software, and then they have building rating system which they are deploying, and they're usually training members. So using software to ensure building sustainability is becoming a big thing. And then green infrastructure. Especially there is a competition which was held last year for green infrastructure designs, right? So it's becoming a big trend right now in engineering and construction. It's beyond just architecture, because that's what architects have been doing green buildings. It's now coming into engineering. Can you also do green structures, green infrastructure? The other digital trend is something which is pretty obvious, but you probably don't even notice it as a technological trend, and that is collaborative platforms and cloud computing. So collaborative platforms and cloud computing are essentially you being able to collaborate with other people virtually or in anything, right? So I think you can identify the first logo. The first logo is Microsoft Teams, which is basically video conferencing. That is collaboration for meetings. The second one is Word 365. I could have done Google Docs still. That's collaboration on report generation. The third one is Google Drive. If instead of storing your files on your local hard disk in the office, if you store it on Google Drive and everyone can access it, that is actually a collaborative platform using cloud computing. Now, Asana is a project management system. So once you start going into offices or into your own practice, you realize that you need to manage projects. You're managing people, you're managing timelines, you're managing budgetary issues. So Asana is a digital platform that manages the projects for you. And then there is Navisworks. Navisworks is basically a BIM management platform. It's usually called CD, Common Data Environment. So it's a platform where all the data for a BIM model are stored so that everyone can access it. So Navisworks works with mainly Autodesk products, but other softwares can also use Navisworks. And then one cloud computing tool that architects use a lot is Revit cloud rendering. So you probably know about 3D rendering of buildings. So Revit has the ability for you to render on cloud. So are some of the trends in collaborative platforms and cloud computing. Now, the next trend is almost not an engineering trend, but it's probably something I think it's important for you to still know as a budding professional, and that is self-branding, e-learning, and community. Right? Someone mentioned that Titus is active on LinkedIn. LinkedIn is a professional platform where essentially, I answered someone say that the self-esteem that LinkedIn can dent is more than anything else. But anyway, LinkedIn is a professional networking platform where people go there to share their professional exploits and pursuits, to exchange knowledge, exchange ideas. And so it's a good platform for if you're planning to shape your career as a professional. It's a good platform for you to be a member of. There's a lot you learn there. I've learned a lot from, for instance, Titus there, and from other people who I look up to in my career. Twitter, Instagram. For instance, Interesting Engineering there is a page on Instagram. It has 3.5 million followers. One of their posts had 16 million views. So this platform will become a place for you to brand yourself as a professional, to build networks, to create market. And then GitHub. GitHub is a social networking platform for techies. So then there's also e-learning. For instance, Autodesk have an e-learning platform. Graphisoft have an e-learning platform. So e-learning is also a digital trend where you don't wait to learn in class. You can actually just go online and teach yourself or learn from other people, and those are now digital communities. Now, those are the trends which I've experienced in technological trends, which I see in construction, in AEC, architecture, engineering, and construction. So I mentioned something on BIM, which is probably the thing I've explored a bit more. So I want to go a bit into BIM in a few minutes. So BIM used to be a buzzword, but I think people have actually realized that BIM is not just a buzzword. It is a significant paradigm. So what is, you probably heard about BIM before. What is building information modeling? So BIM is a holistic process for creating and managing information for a built asset. BIM integrates structured multidisciplinary data to produce an intelligent 3D digital model of a project across its life cycle. Now, let me break this down. For the longest time, people used to do things manually, by hand. Architects used to draw using drafting tables and pencils on paper. Engineers would do all their calculations by hand and draw the structural drawings by hand. Drafting table, drafting pencil on paper. Then with time, CAD software came. So basically, with CAD software, architects could do 3D representations of the model. They could now draw it on computer instead of using hand. So it just became a digital pen on a digital paper. Same thing to engineers, they could just now draw it on line work. But then, because they were just digital representations and not actual models, you can't do analysis on them because they're just lines, digital lines on digital paper. You cannot test for their fire rating, you can't test for their resistance, you can't test for their, how they will behave under loads. If you cut a section, you cannot see the different layers. You can't check for their cost. And so that's now where BIM comes in. BIM is about modeling information into your building or structures models. So that if I cut section anywhere, for instance, in a building, I actually see the building as it is. If I decide to apply loads on it, because there's actual information on the column, there's actual information concerning the class of concrete, the size of steel and things like that, you can apply loads and see its reaction. So BIM is about how much information is in your model. And it covers the whole cycle. It begins, all the way from data collection to conceptual design, to detailed design, and to analysis and simulations, to documentation. You want to have all this information model into the computer, so you can even do automatic documentation, automatic annotations, to fabrication, because the information actually has information, you can now go and fabricate these things, mass produce them, to construction. So for this, basically, if you model in time into your model, so that means I create a model and I say foundation 2 weeks, slab 4 weeks. So once I create the digital model, someone can actually create a work schedule from the digital model. And then 5D is cost. You model in cost into the model itself, so you can create, you can generate BQs. And then construction and logistics, so that's where AR comes in, VR comes in, using drones for site inspection, laser comes in, NDTs, those are non-destructive techniques come in, and there's the operation and maintenance, and then renovation. So that's the whole life cycle of BIM in a project. And so there are some tools, for instance, in data capture that I have explored in my practice. I mentioned that I have a passion for artificial conservation. So the screenshot there is a project we did in Mombasa, where we used 3D laser scanning to document the building. Right? So we basically 3D scanned the whole building and then converted the 3D laser scans to a digital model. So in the early stages of a 3D BIM, of a BIM project's life cycle, the first step is, of course, data capture, capturing whatever is on ground. So one tool you can use is laser scanning. Another tool you can use is photogrammetry. So laser basically uses laser technology. Photogrammetry uses normal camera technology. So it basically pieces together many photos of a project. and then creates for you a 3D model based on the photos taken. And then the next step is, of course, now when you start modeling. So when you start authoring the model authoring, that's basically translating and developing the design intent into a parametric BIM-based model that people can use. Right? So I've talked about it. A BIM model is a model which is information rich. These days, you can even integrate GIS data into your model. So if you want to become a BIM engineer, right, there are many BIM architects, there are many BIM QSs. So if you want to become a BIM engineer, what will you be doing? So as a BIM engineer, you will be designing systems using BIM methodology. Basically, you'll be doing systems that have information in them so that you can easily coordinate with other people. You'll be producing documentation, schedules, and material takeoffs automatically from the BIM model because all the information is in it. And then, of course, you report to BIM coordinator. A BIM coordinator is basically a guy who takes a model from a BIM engineer, takes a model from a BIM architect, and combines them because all of you are working on the exact same model. And then you now work with other co-engineers. So co-engineer is basically an engineer who is not a BIM engineer. So he has all the design information, analysis information. Now you come in to be able to do that for him using BIM software. And then you also train other BIM modelers. So I think that's largely, that's probably largely Titus' field, because if he was first a co-engineer and then he became a BIM engineer and he's sharing information on how to use BIM for engineering. So after that, once you've modeled a building, the next thing is to analyze it and to simulate. So you basically perform analysis and simulations for better informed design decisions. So examples of simulation are things such as flood simulation, parking space allocation, structural analysis, and I think there's some softwares which, for instance, there are softwares which we use in our office for this analysis and simulation. We use Autodesk Civil 3D. So that's for the engineering department where I work. They use Autodesk Civil 3D to basically do 2D designs and 3D designs of the project. They can input survey data, benchmarks, contours, and stuff like that to generate topographies. And then it can also do quantity takeoffs. So usually I see their workflow is they use Autodesk Civil 3D, and then they take it to Procon, where the engineer does all the calculations. You can also do 2D design and do 3D modeling. Usually you see them using Procon to do the calculations, and then move it to Prota, where they do the analysis, so applying loads and doing the analysis. It's a structural analysis and design software where you can create now the different, the different RC details, steel connections. And the good thing is that you can now move it to Revit. So once he does that, he moves to Revit, because now with Revit, while Revit can do both design and detailing, but here they just use it for collaboration, because now the architects often use Revit to model. So they combine a Revit model with now the architectural model from the engineering model from Prota. So that's basically design collaboration. That's analysis and simulation in BIM, and then there is 3D model viewing. So BIMX is a tool that architects use to be able to visualize the BIM model for, let's say, clients. So essentially, as an architect, I might be interested in all the minute details. Probably I think the same thing for engineer, but the client also there just wants to see, okay, how is it coming up, right? So that's where 3D model viewing apps come in. So you can cut a section through a 3D model viewing app, and you can walk through the 3D model viewing app, and it's because it does not have all those details that are usually in modeling software. It's very light. For instance, BMX, which I use, can even have it on your Android phone or on your iOS phone. So you can send your model to a client who is on Android, and he checks the model and he cuts through the sections and he sees the elevations and he's like, that's okay. So, and then you can now use this with VR. This 3D model viewing apps, usually you can combine them with VR. So if someone wants to walk, if a client wants to walk through the space, maybe we're working on a plant, on a factory, the client can just wear 3D glasses and walk through the space. So yeah, 3D model viewing is also good for design review. initially architects used to work on only 2D, then started working on 3D. I'm seeing engineers are also following quickly. For the longest time, engineers have been stuck on working with 2D. I'm seeing engineers also now starting to use 3D when they are doing the designs. So that's a benefit of BIM. You can now visualize your models in 3D as well. And then finally, quantity takeoff. So once you've done all your models, so this is a screenshot of a model I had done. So I modeled it on ArchiCAD. I keyed in all the information, all the material information, material volume, and stuff like that. And now I was exporting it to Excel sheet so that the QS can just go and input in the rates, right? So that's an advantage of BIM model, because everything has been modeled in. That's the idea behind the digital twin, because everything has been modeled in. Your artificial members for my case, and then engineering members for an engineer's case. Now you can quickly generate a schedule of anything you want: door schedule, window schedule, schedule for wall surfaces to calculate paint, amount of paint, wall surface areas to calculate amount of paint, wall lengths to calculate the number of stones. So same thing can also be done for steel and concrete to be able to calculate volumes, and that will now be useful when you're doing quantity takeoff. So there's a BIM software, spreadsheet software link to generate material quantities. So that's the whole landscape, the whole overview of BIM deployment, which I think you might probably be interested in as a civil engineer. Yes, and I think with that, I want to now take in questions, if there have been any. Before I probably now attempt the moonshot video one more time, and then close. So Martha says, what do you think is the biggest challenge in integrating technology into architectural and civil engineering practices? Share your thoughts. I share my thought, and then I think I will welcome Titus to also share his thoughts from an engineer's perspective. Let me see if there's another question. So there's a question from Jim, digital twins versus as-built drawings. I think I responded to that. I think there are several challenges. One is that there has been minimal exposure. I just discussed with a friend of mine that among architects, for instance, the senior players have very little information about what tools are out there. At least the younger players, the younger professionals are coming up a bit more adeptly. But for the senior professionals, many of them do not know. But now, because the younger ones are working in their firms, they need their resources to be deployed in tech. But now, if someone does not know why, ArchiCAD 17 is still working, why update? Right? AutoCAD 2D is still working in 2012. Why go for Civil 3D? Why go for ETABS? Why pay for these licenses and stuff like that? So I think that's exposure is the first challenge. The second challenge is expertise. Not many people know these softwares, and even those who know it don't know it well enough to take advantage of the full BIM capabilities. So we are just basically touching here and there bits and pieces of actually what tech can do, right? And that's just BIM. We've not even gone into how much machine learning can affect, how much AI can affect our practice, how much cloud computing can affect our practice. So there is so much that is out there that you're not even tied. Now, 4 is cost of implementation. You realize that many of these things are actually being done abroad, but when you come to Africa, maybe the scale of our projects is not that much. How much clients actually pay for this project is not enough to motivate practitioners to invest in them. And then 5, we have not had an integrative teaching system. There's a time I was checking out the summer decathlon. I think should be somewhere in Europe, and what happens there is that students during the long holidays, so to speak, summer break, students from different fields collaborate on a competition. So you probably have a team that has an engineer and an architect and a QS, and this and that, and then you come together to come up with a project, design it, and then create a prototype of it. and that is just, it's beautiful for you to be able to do that in school, because in school you learn so unidirectionally. You never learn how to partner with other professionals, what they do, how important they are, and how to collaborate with them. And so architects come out and they believe that they're the only people should speak in a site, and engineers come out and they feel like architects are just these guys who know nothing about math. And then there's all this conflict, because they were never taught how to work together. So I think, to me, that's the challenges at first. But I think, Titus, we probably could do in a minute or two. What do you think are the challenges that from the engineering side is facing integrating technology into the practice? Before I take the question from Ahmed and respond to Jim.
So, hello everyone. Hope you can get me.
Yeah, we can.
All right. Okay. Maybe I was not prepared for this one. I think we can learn. Times listening to what other people are doing is essential, and you can learn a lot. And the good thing is you've already done the research for me, so I can learn without having to do the research. So that's why I like making time to listen to these things. I also think at times that engineers are not mostly not engineers. People in the AAC sector need to make time to learn from one another. It's probably the easiest way to grow in many of these aspects. So thank you, Brian. Those that are in engineering, make a friend who is an architect, right? Right. So, and also know that Brian is my senior by the simple virtue is an architect. So thank you.
Thanks, Titus. Yeah, I think in engineering that has been the biggest challenge in engineering. The engineers have just Titus, there's some I think Titus can meet. Yeah, with engineers, the challenge mainly has just been engineers have not been exploring tech so much, and probably it's because of the manner of their instruction. Anyway, Jim asks a question: What are my thoughts on the potential ethical implications of integrating AI in AC? One, I think we're still in the very early ages of exploring AI, so there have been issues about how accurate AI actually is in AC. Yeah, I saw some guy experimenting with generative AI, creating design details, and the details were off. So if you depend on them, you'll end up doing wrong specifications and like. So AI has not yet learned enough to be able to be trusted, and Shidani AI never admits that it does not know. So it will just give you a response. Two is there is issue of bias. The problem with AI is that AI garbage in, garbage out. So the one challenge that has been facing AI is that AI is essentially trained with data from US and Europe. So and you know how we build and how they build is different. So when you use AI to create to generate information, it will give information that is more fitted for Europe and Africa and for Europe and America. Yet we need to have something more contextualized for our climate, for our challenges and the likes. The other issue is the issue of data privacy and security. I mean, AI depends on being fed with data, and sometimes, there's issues of data being leaked out, data being misused, unauthorized access to data, and such things. The problem is that you can't question AI. AI just gives you responses, and sometimes there's a lack of transparency. With a human, you can try and check what's their thought process behind it. With AI, the thought process is the data that was fed in, and you can't ask AI to tell you who fed in that data. So, and sometimes you don't even notice it. So there's been issue of transparency. There's of course the recurrent issue of job of something called technological unemployment. Essentially that AI can come and remove some people from work. But I love that quote I read somewhere. It said, AI will not remove you from a job. Someone using AI will. But of course, it's a reality that if AI comes and automates some of these tasks, then those people whose only contribution was doing tasks that can be automated will lose job. So now for you to learn how to do things which cannot be automated, right? If all you do is calculate, a calculator will remove you from your job. If all you do is compute, a computer will remove you from your job. So you now need to learn how to go beyond what a computer can do. There's the issue of we think of something. I think those are the main issues. There are, of course, social issues. It may probably increase inequity. Is it inequity? Lack of equity, lack of inequality. Yeah, there may be increase in inequality because those who can access AI will now be able to grow faster because they can be able to churn out more work. And those who cannot afford AI will now suffer. You know what Chinese have basically done to Kenyan contractors. When they compete, but they have everything on their side, and so they end up winning every single time. So that it may perpetuate such an inequality. There might be issues with compliance because now AI, AI cannot be arrested. So there was this issue about driverless cars. When if a driverless car commits a traffic offense, who will be prosecuted? So same things might come into use of AI in AC. Yeah, and of course AI has no feelings, has no emotions, has no empathy, and sometimes decisions that we make need to have those things. So AI cannot feel. So you'll be having very impersonal work relations and employees. These are some of the AI issues I can pick out. Ahmed, you have lifted the hand. I think you'll be the last person before we do our moonshot video and then we close.
Thank you, Brian. My question is about AI as well. I recently read about I think it's a recent software by Autodesk called Forma. I don't know if you've come across it, but have you ever used it? But I read that they're using artificial intelligence in the software. It's related to construction in the industry. I said Forma it deals with the AC industries as well.
Yeah, I've tried with Forma. I've not tried with Forma using AI. It's more of a conceptualization model. I think Ahmad has actually posted that. It's a cloud-based software that will unify workflows across teams that design, build, operate, build deployments. Yeah, so I've used it a lot, mainly for conceptual. I was actually learning it for conceptual design. The good thing with, I've not used it now with AI and its predictive analytics. I'm seeing that it has predictive analytics. I was just learning it for the sake of conceptual design because it has a very simple modeling approach, and then it can be used for energy simulations and other kinds of simulation. So I'm still learning it. I actually started learning it like 3 weeks ago. So I can't say a lot about it, but I think the good thing with Autodesk is that Autodesk has a whole platform with tutorials and case studies and testimonials on their software. So maybe you can check it out. Yeah, I'm more of a Graphisoft side guy than an Autodesk side guy, but I'm trying to also get into Autodesk. But that's a good question. Yeah, so I hope that helps. Jim, yes, please.
So still on the last bit you said about the social aspect of integrating AI in AEC. So now my question hovers around, I'm not really sure if it's philosophical or social, but integrating AI into mostly architecture. Now, do you think the architects will lose their relevance, or rather, because architecture is a deeply human endeavor in a way that it is art, it connects, it puts people's emotions into consideration. So because AI, as you said, has no feelings, so does that mean architecture now loses significance in the, now aside from functionality, now this other meaning that architecture has as far as people's culture is concerned, their emotions and their philosophy around art in construction.
Okay, thanks. So I think I'll respond to that, and then that will be the last question because we are 20 minutes beyond time, and I'm not wish to keep people longer than that. There'll always be that challenge about means some things might be lost when AI starts doing these things, and of course AI is getting smarter and smarter. We don't know where AI will be 5 years from now. Will they learn to probably replicate what human emotions look like? I'm not sure. Will the prompting get better and better to the point where you can prompt something that responds to your feelings? I'm not sure. What I would just say, because I mean, the rest of that will be primarily speculative. What I would say is, for everyone as a professional, you need to be able to, one, study the trends, see where it is going. And then two, identify what are you offering uniquely as a human that a computer cannot offer. So for now, for instance, a computer offers a listening ear. So you can imagine maybe there's a client somewhere will just go online. There's a video on YouTube on architect versus AI. So it's done by some Chinese architect called Li. And he was comparing AI tools with an architect. So he prompts an AI, generate for me a 2-bedroom floor plan, and then it's like goes to a AI rendering tool, and generate for me 3D renders for this plan, and then generate for me elevations for this 3D render, and then generate for me drawings for this 3D render, and then generate for me a 3D model for these drawings, and then finally, and of course, Rhino is what is someone trying something that combines Midjourney and Rhino. Either Midjourney or Veras and Rhino. That's image generation software and a 3D modeling software. So it's becoming smarter and smarter. So to me, I would say at the moment, AI may not phase us out. It might automate some tasks and phase some people out. But the best thing would be for you as a practitioner to study how can you harness these technologies to improve your workflow while still offering that which AI cannot, right? You can listen to a client, listen empathetically, study how they live and try to understand their needs best, understand where they stand financially, what is their culture and background, and now incorporate these things into design. That AI cannot do. And then once you have conceptualized the solution for the client, now use AI and all these other digital tools to now fast track the process, increase your efficiency, increase your accuracy, increase your time. So we're probably not at that point where AI can replace us that much for us to actually grapple with those risks. But I think once we get there, we'll not really do anything about it. There'll be clients who want time over and listening ear, and so for them they'll go AI, they'll go mass production. But there'll be clients who actually want a designer who listens to them, and those ones will come to you. So I hope that helps. So there we go. I see Engineer Titus' hand. So I think for the sake of my good brother, you can probably just have you giving a closing comment, and then I will turn the task back to Mark. Yes, Titus.
Okay, thank you. Maybe to add something little on what you have said. It's also good to understand where the market is currently, and then you grow a skill that is beyond the market. So there are things that are in the market that are currently news, and there are things that are entering the market, especially the AAC market takes time to adapt to new trends. It also takes a bit of more time to make products that can help out people doing that work. So the best thing is always make sure that you learn your skill, simply because if you go to an engineer and they ask you, can you use AutoCAD, can you use some of these simple things, at times you may find yourself, so make sure that you learn what is currently being used in the market, then grow beyond that.
So grow into other passions that you want to do. If you want to check out something in AI, try think Tango Builder, something about analysis. I'm here to check it out, but I thought of checking it out. Tango Builder, so it's one AI about analysis. It says real-time analysis, so I'm here to check it out. So yeah, thank you.
Thank you so much. That is actually Revit for Engineers trainer. You can check him out on LinkedIn. Then go there and support him and learn from him as well. So, Martha, thank you so much for hosting me and thank you for your time. I'll play this video at the end of it. You can take it up right away. I think I've overstayed my welcome. I have appreciated your patience. And all of you, for the students in this place, all the best in your career. I pray that you might grow beyond your heights. You might grow beyond your present dreams, and you might go there out there and change the world. For those already in the field, let's partner together, let's collaborate, let's go back to our schools where we found our roots, and let's inspire them, motivate them, mentor them, and let our joy and our legacy be to see young people become better than we. With that, peace and out. Oh. Why did everything work except this video? Guys, this video has refused. Back to you, Martha.
Okay, I will just be providing my closing remarks. Jack was to take over from now, but I think there is nothing actually to take over. I'll be providing the closing remarks as well as Felicitas. I'll be representing IEEE Photonics. We are also part of the organizing team. Yes. And I've received a lot of questions on where photonics applies, even in civil, in all this. And photonics is everywhere and anywhere. And I'm pretty sure, even on a couple of slides back, he talked about how they captured data using a 3D scan. I am pretty sure they used light-based technology. And light-based technology is basically photonics. And yeah, even among the latest trends I've been seeing recently, it's using deployment of optical fiber sensors for data, like such as deformation analysis, to allow for monitoring and proactive maintenance. And that's a really great initiative. And yeah, don't be scared to join IEEE for the members in the meeting. And yeah, otherwise the presentation was amazing, and I will definitely be taking time to reflect on the insights that I have been I've captured from the session. And I'm gonna leave us with one last message. They say there are many good engineers, but few great ones. And indeed, what sets apart the great ones is their willingness to take bold steps and push boundaries and to challenge the status quo. Yeah. So, okay, nobody says that. I say that. But so basically, why should we settle for the basic when we have the opportunity to soar for new heights? Yeah, and I believe what engineer titles have said is actually basically summarizing that: stay ahead of the trends, stay ahead of the market, keep tabs, try to stick with the trends, and even be you can be as innovating as you want. You can provide your new products as well. What's stopping you? So yeah, thank you all for coming to the meeting, for attending the meeting, the webinar, and I hope to see you again in the following events that we might have. Jack, you can take over. Sorry, Felicitas. Yeah, we'll be talking on behalf of women in engineering. Felicitas.
Okay, hi guys. My name is Felicitas. I'm from IEEE, Women in Engineering, and I'm also doing civil. I had a very wonderful time. I've learned a lot, and I'm sure the rest can say so. BIM is a very interesting space to be in. and I have definitely gotten more information on that. Women in engineering, of course, we are under IEEE, so you are mostly going to find we take everyone in, yes. Women and men, you're all welcome to Women in Engineering. Its main mission is to promote technological development and to support women while doing that. So, yes, I don't think there's any more I can say. I just want to say thank you to Brian for this very wonderful session. Thank you.
Oh, before I forget, I never introduced myself. My name is Martha Njuguna, 2.2 students, at 2.2 civil engineering student. And yeah, thank you. And you're all free to leave the meeting at your own way.